Welcome students to the welcome everyone to the third lectures in the statistics. Now this is a series of videos on the statistics which you can use for your CF and FRM preparation and along with the data science and actuarials and machine learning basics. So today in this third lecture, we discuss, as we have promised in the last session, that we'll discuss moments. And in moments, we'll first discuss moment one. If you haven't watched the previous video, that's fine. We'll start from the basic itself. And it is a very basic video because it's all about central tendency in the data. Moment one talks about the central tendency in the data. And there is a very important concept that we have to understand that is called as blue. Not red, blue. Best linear unbiased estimator. Okay, with that, let's start this session. Okay. So first of all, we have to understand that what is the center of the data. So assume this is the data and I want to describe the data, the first thing that comes in our mind is to find the center of the data. So this is the center of the data. Now, what are the different ways through which you can find that one single center for the data? There are multiple ways. Let's see. One of the method or one of the measure through which you can find the center of the data we all know is mean. The second is median, and the last is mode. Mean, median, and mode. The three ways you can find the center of the data. But the question is, why three? Why not one? And which one is the best in all? That is what we are trying to answer here. That why we cannot use one of them, or is it that we have to use one of them for the specific use cases? So that is the discussion here. Okay, let's start with mean. We all know what mean is. So for example, if I have, say, a historical data, I have a historical data. And because we have to connect this statistics to the real life example, that's why I have taken stock return. So if I have historical data, which is historical return, which is 4%, 2%, 8%, 9%, and 10%, and if I have to find the mean, if I have to find the mean, in a very simple way, what I'll do is, if you want to find the mean of the data, what you will simply do? What is the formula for mean? The formula for mean is summation of xi, where I varies from 1 to n, divided by n. So what you will do? You will take the summation of what? 4, 2, 8, 9, 10, and divide by 5, and then you will get the mean, right? But if the question changes, and the question is that based on the historical study of 5 years, definitely the return is 4%, 2%, 8%, 9%, and 10%. But I haven't studied like 5 month data or 5 year data. I've studied the historical stock return till the inception of the stock. Or I've studied like 5 years of monthly data and I found that there is 15% probability that the stock return would be near 4%, 20% probability that the stock return would be 2%, 5% probability that the stock return would be 8%, and 25% probability that the stock return would be 9%, and so on and so forth. Will I apply the same formula, summation of xi upon n? No. Now the equation has changed. Now you have to apply a different formula for mean, and that is summation of pi into xi, where pi is the probability of individual data, where I varies from 1 to n. This means you will do mean is equal to probability, that is 15% of 4% plus 20% of 2% plus 5% 5% of 8%, 25% of 9%, and 35% of 10%. So you will do 0.14 into 4 plus 0.20 into 2 plus 0.05 into 8 plus 0.25 into 9 plus 0.35 into 10. See, you can solve this question, but the biggest question that we have to answer here is that which formula to use. Whether the formula of mean is summation of xi upon n is correct or whether summation of probability into xi is correct. Actually, if you look carefully, then this is the general formula and this is the correct formula. This formula is the universal formula for the mean and it should be applied everywhere. Then what is this formula summation of xi upon n? There is one assumption. If you look at this formula summation of xi upon n, there is an assumption which is hidden. The assumption is, the assumption is, the assumption is that that every data point has equal probability of occurrence, has equal probability. So basically, this is using this formula only, but mu is equal to summation of pi into xi. This pi is assuming that the probability of each data point is equal. So if there are 5 data points, what is the probability? 1 upon 5. So therefore, this probability becomes 1 upon n. So what is the assumption? The assumption is that every data point has equal probability. So what is the universal formula for mean? It is summation of pi into xi. That's it. Okay. Now let's move into a very basic notation for mean. Now, if you are playing with the population and assume this is the population, this is the population. Okay, this is the population. As you're studying the whole data, maybe India population, age of every person in India. And if you try to find out the mean and somehow you studied each and every person's age in India, and that is called as population mean, and the notation is mu. The notation is mu. But because of the time constraint, you're not able to study the whole population, and that's why you might have studied a sample and you found the mean of the sample. Whichever formula you apply, you find the mean of the sample, and the mean notation is x bar. X bar. So this is the notation. I'm specifically talking about the notation. This is the notation for population mean, and this is the notation for sample mean. So we discussed about the mean. Let's move into mode. Let's discuss first median. As we discuss mean, let's discuss median. So again, this is the historical return. 4%, 2%, 8%, 7%, and 10%. What is median? Let's understand it first. So we have completed mean. Now we'll understand median. With the same example where we have historical data and we are taking a financial instrument, which is stock, and we are saying the returns are 4%, 2%, 8%, 7%, and 10%. Let's find the median. What is median? What is median? So median, in a very simple sense, it is a line, which bisects the data into two equal halves. That's it. That is median. But before that, you have to either arrange the data in ascending order or descending order. You cannot use the data as it is. So let's arrange this data in ascending or descending order. For this session, we are saying let's take ascending 2%, 4%, 7%, 8%, 10%. You can also choose descending order. It is up to you. Now let's take a line. Now let's take a line which bisects the data into two equal halves. So this is that line. I hope you can see this. So this is the line which is crossing from what? 7%. So what is the median? The median is 7%. That's it. So median is 7%. That is the center of your data. Now, what if the historical return is 2%, 4%, 8%, 7%, 10%, and 33%? Let's first arrange the data into ascending or descending order. So 2%, 4%, 7%, 8%, 10%, 33%. Earlier, the data was odd. So it was easy to find the line to bisect the data into two equal halves. So here you can see that we have two data points. Here we have two data points. But now if I take one line, what would be that line? That line is not going to pass through a number that we know. It is going to pass between two numbers. That is 7% and 8%. So basically, you have to take the average or midpoint of 7% and 8% to find that point from where the line bisects the data into two equal half. So this point, so basically what you're doing is interpolation. What you're doing is interpolation and you're finding the midpoint. So 7.5% is the center of the data if you're calculating the median. Okay. So if you have odd numbers of data, you can find ED. If you have odd numbers of data, you can find median easily. If you have even number of data, you have one more step that you have to take the average of the two data point. You have to find the average of the two data point, which is to the left and the right of the line that bisects the data into two equal half. Okay. So here, the data in the left and the right of the point where the line bisects the data into two equal half is 7% and 8%. So we have taken the average of 7% and 8%. If the number would be 10% and 12%, you would have taken the average of 10% and 12%, which would be 11%. Okay. Now, last is mode. What is mode? What is mode? Mode is the data point. Mode is the data point with the highest with the highest frequency. With the highest frequency. Okay? What is the meaning of frequency? The data which have the highest occurrence. So we have 4%, 2%, 2%, again 4%, 8%, 7%, 10%, and 2%. So you can see 2 is occurring the highest number of time. So that is my mode. So 2% is the center of the data if you calculate the center through mode. But what if you change the data? You change the data and you make it 4%, 2%, 2%, 4%, 8%, 7%, and 10%. Now you have two mode, 2%, 4%. Earlier, when my data was 4%, 2%, 2%, 4%, 8%, 7%, 10%, and 2%, I had one mode. Now I have two modes. So this is a bimodal data, and which is counterintuitive from the concept of center. Because if this is my data, I want to have a single center. Now you're saying there are two center of a data, right? But the problem doesn't stop there. If you say that 8% is another data point. Now it is a trimodal data. So what I'm trying to say that mode has a problem. The problem is it can be multimodal and it is not good for us. Multimodal data is saying there are multiple centers to a data, which is very, very different from the concept of the center. It is counterintuitive. But the problem doesn't stop there. See this data. What is the mode of this data? It doesn't exist. It doesn't have any mode because every data point is occurring once. So there is no mode to the data. You don't have a data point which is occurring for more numbers of time. So that is a problem with mode. And similarly, there is a problem related to mean. There is a problem related to median. Let's understand the problem in median and mean. Now, what if the data is, say, 4%, 5%, 6%, and 7%? If I ask you to calculate the mean would be 5.5 and the median is also 5.5. Perfect. Now, what if to I change 7% to 70%? The median will remain 5.5, but the mean, if you calculate the mean, 4%, 5%, 6%, and 70. So it should be 85 divided by 4, that is 21 and something. It would be 21.2 or 21.25, whatever it is, 21. Let's take the number is 21. What you have observed, earlier the mean was 5.5. Now the mean has shifted to 21.25 just because of an outlier in the data, just because of one extreme data point Just one extreme data point. I have just taken four numbers. You can increase it to 4%, 5%, 5.5%, 6%, 6.5%, 7%, 8%, and then take an outlier like 700. Mean will drastically change its center just because of one outlier. Mean will shift drastically. However, if you see the median, the problem with the median is it won't change at all. It should change because there is a significant change in one data point. So definitely change from 5.5 to say 5.75, because and there is a data point in the data which have very extreme value, so it should change. So the problem with the median, it doesn't change. So what I'm trying to highlight, that each one of them has certain problem. Mean has a problem that it is very sensitive to outliers. However, median has a problem that it ignores the magnitude of the value. Even if you have an outlier in the data, it will deny to shift. It won't shift at all, which is also bad. Both the extremes are bad. And what is the problem with mode? That it may not exist and there would be multiple centers like multimodal data, bimodal data, or trimodal data. Definitely, I have written more problems related to mean, median, and mode. You can pause the video and talk about all the problems, but these are the critical problems. So the question is, which one to use? Which one is the best? Is it mean, is it median, or it is mode? Statistically, most of the time when we choose a measure, whether it is best or not, we use a very simple term, that is blue. Not red, not green, blue. Blue stands for best linear unbiased estimator. Best linear unbiased estimator. The multiple meaning of blue, but there are two critical one. It should be unbiased. We'll try to understand what is the meaning of unbiased at a high level. And it also means the another interpretation of blue in the terms of unbiased is that whichever measure you take, the deviation of that measure should be the least, or the variance of that measure should be the least. Now, the problem is we haven't understood deviation or variance. That is moment two. So, what is the way we can understand best linear unbiased estimator? Okay. I'll first try to explain you with a very simple example. Assume this is your data and you're trying to find out the center of the data. Now, if you use mean, if you do the first experiment, this will be your center. Mean will calculate this as your center. If you do the second experiment, mean will say this is your center. If you do the third, the mean will say this is your center. If you do fourth, then mean will say this is your center. On an average, mean will always say, if you take the average of all the experiment, and if you take the average, it is going to be the true center. It is going to be the real center. But this is not possible in median. For example, it is possible in median sometime. So if you if you do the first experiment, this is the center from the median. If you do the second experiment, this is the center from the median. If you do the third experiment, this is the center from the median. If you take the median of all the median, it is not going to be the center, the true center. And the same is the problem with mode. So assume mode is going, if you if you took the first experiment, then this is your mode. If you took the second experiment, this is the mode. If you took the third experiment, this is the mode. And if you take the average of all the modes, it is not going to be the true center. Let's prove it. Let's prove it mathematically. So this is your population data. When I say population data, it means it has all the data. It is the exhaustive data. 2, 2, 3, 3, 4, 5, 5, 8, 1, 2. So 2, 2, 3, 4, 5, 5, 8, 1, 2. And assume this is the center of the data. Now we have divided this whole population into two samples. This is one sample. This is one sample. What you will do? You'll first calculate the mean of both the sample, median of both the sample, and mode of both the sample. Then what you'll do? We'll take the mean of the mean, and you will be surprised this is equal to the population mean. But when you take the median of the sample, it is not equal to the population median. And when you take the mode of the sample, it is not going to be the population mode. Okay, it is only in the case of mean that the mean of the sample mean is going to be the population mean. Okay, so sample 1 is 2234, sample 2 is 55812. Let's calculate the mean. So it's 2234, and this is 55812 upon 4. Median median of sample 1 is 2.5 because it is arranged data, and for sample 2 is, it is the center between 5 and 8, that is 13 upon 2, and mode of sample 1 is 2, and mode for sample 2 is 5. If you take mode of mode, there is no mode at all, or you can say 2 and 5 both are mode. But if you take the whole population mode, it is 2 and 5. Here the mode doesn't exist. Okay, it's 2.5, and this is what? This is 6.5. If you take the median of 2.5 and 6.5, 2.5 and 6.5, the median is 4.5. This is the median of the sample median, which is 4.5. But what is the population median? The population median is luckily 4.5 in this case. It's luckily 4.5 in this case. If you change the number slightly, make it 6, the median will change, and it is not going to be equal to the population median. So sometime, even I have written that, sometime median throw an unbiased estimator, but not always. It's not true. Sometime median does. Mode never. Mode of sample mode is never going to be the population mode. But the mean of sample mean is always going to be the population mean. So if you take the mean here, which is 4, 8, 11, 11 upon 4 is 2.30 2.75, and 30 upon 4 is equal to 7.5. 7.5 plus 2.75 divided by 2. So if you take the mean of the sample mean, it is going to be 5.125. If you take the mean of this whole, let's take the mean. 2 plus 2 plus 3 plus 4 plus 5 plus 5 plus 8 plus 12 divided by the number of data point is 8, it is going to be the population mean. And that is what I'm trying to say. That if you take the median of the sample median, sometime it is going to be equal to the population median. But if you take the mean of the sample mean, it is always going to be the population mean. And if you take the mode of the sample mode, it is never going to be the population mode. And that's why the mean is called as BLUE, best linear unbiased estimator. Now in BLUE, there are multiple words. It is linear, it should be what? Unbiased. And what I have said, which we cannot discuss right now, it has a minimum variance. It should have a minimum variance. And all these are possible in mean. And that's why mean is BLUE. However, median sometime be unbiased. Okay. So with that, we have understood what is the meaning of BLUE. We understood that mean, that's why it's called as the best linear unbiased estimator, and that's why mean is used as the center of the population most of the time. But you should also keep in mind that if there is an outlier in the data and mean is deviating a lot, because of that outlier, you should be using some other measure like median and mode. Okay, with that, I'll pause moment 1 here. In the next session, we'll talk about moment 2, which revolves around the dispersion in the data. We'll try to understand the formulas of variance and standard deviation. So with that, thank you. Have a nice day.